us to another episode on ASUG 12 exams. So in this episode we continue looking at the 2021 GSCE Science Paper 1. So this is basically physics. So now we are looking at section B, which carries 45 marks out of 85. So let us start with question B1. Figure B1.1 is a diagram showing the reading of a Vernier calipers. Question A. What is the reading shown on the Vernier calipers? So in this case what we do is we need to obtain two readings, the reading from the main scale and the reading from the Vernier scale. So remember, it's important to understand what you're being asked to do. So in this case we are asked to get the reading shown in this figure. So this is basically the main scale, then this is the Vernier scale. So let us call the main scale to be MS. So what is the reading? So we know this is 5, then this is 6. If you count between 5 and 6, we have 10 subunit, and this is half, which is 0.5. So we have 0.1, 2, 3. So we have basically 5 centimeter, 0.3. So 5.30 centimeter. Remember, always when you are getting the reading from the main scale, you get it to 2 decimal places or more. But in this case, 2 decimal places should suffice. Then we go to the Vernier scale. So when you are reading the Vernier scale, you need to look for the point where the line on the main scale and the line or the mark on the Vernier scale, they are straight line. So what you notice here is at this point they are in straight line, and the subunits on the Vernier scale, it is also 1. So we have 1, 2, 3, 4, 5. So this is 5. So where they are meeting at this point, this is number 3. So basically on the Vernier scale VS, we start with 0 point. So 0 point, then 0.0, then this is 3, so we will write 3. So these are in centimeter. Then we need to add these two. So we are going to get a 0 plus a 3, we get a 3, then 3 plus 0, we have a 3, then 5 plus 0, we have 5. So we end up with a 5.33 centimeter. Remember, the reading here is in centimeter. So 5.33 centimeter is our reading. Then we look at B1, Roman numeral 1, convert the reading in A above 2 meters. So for B, Roman numeral 1, we know that how many centimeters are in 1 meter. So we have 100 centimeters making 1 meter. Then we are told to convert this 5.33 centimeter to meters. So we are looking for conversion to meters. So this will be x is equal to 5.33 centimeter. Then we cross multiply. We're going to end up with 100x centimeter basically equals we cross, then it will be 5.33 centimeter meter. Okay, so what you notice here is in this case we divide by 100 centimeter, then by 100 centimeter. So what you notice here is this centimeter and this centimeter cancels, this 100 and this 100 cancels, then we remain with x is equal to, similarly this centimeter and this centimeter cancels, then 100 into 5.33 we end up with 0.1 0.533 meters. Let us look at question B2. A man of mass 75 kg on Earth goes to the moon, where the gravitational field strength is 1.6 Newton per kg. Question A. What is the mass of the man on the moon? So the question is asking us to find the mass. What is the mass? So the mass is basically the amount of matter present in an object. So it's basically the amount of matter contained in an object. And the amount of matter contained in an object does not depend on the place. It remains the same whether you're on the moon or you're on Earth. So basically, based on that fact, we know that it's the same mass that we've been given, which is basically 75 kg. Question B. What is the weight of the man on the moon? Then the weight, basically we know that is basically the force acting on the mass of an object. And weight is given by mass in kg times gravity. So have we been given mass? Mass is 75 kg. Multiplied by what is gravity? So gravity we've been given is basically 1.6 Newton per kg. Then if you multiply, you know that this kg and this kg cancels. Then 75 multiplied by 1.6 will end up with 120 Newton. So 120 Newton is basically the answer. Let us move to question C. A light truck of mass 2000 kg accelerates from rest at a rate of 1.5 meters per second square. Calculate the force required to accelerate the car at this rate. So we know that force which we are asked to calculate is given by mass times acceleration. Have we been given mass? We've been given this one, which is 2000 kg. Have we been given acceleration? We've been given to be 1.5 meters per second square. So we substitute. 2000 is in kg. Remember, mass is always in kg multiplied by 1.5 meters per second square. Then we are going to end up with basically 3,000 Newton. So 3,000 Newton is basically the required force to accelerate the car. Because if this force that we apply is less than the force acting on this car, it will not move because it will be less than that. It will maintain. If it's equal, it will maintain. So it has to be at least this to accelerate the car. So basically, this is how you answer this question to get the 5 marks. Let us look at question B2. A man of mass 75 kg on Earth goes to the moon, where the gravitational field strength is 1.6 Newton per kg. Question A. What is the mass of the man on the moon? So the question is asking us to find the mass. What is the mass? So the mass is basically the amount of matter present in an object. So it's basically the amount of matter contained in an object. And the amount of matter contained in an object does not depend on the place. It remains the same whether you're on the moon or you're on Earth. So basically, based on that fact, we know that it's the same mass that we've been given, which is basically 75 kg. Question B. What is the weight of the man on the moon? Then the weight, basically we know that is basically the force acting on the mass of an object. And weight is given by mass in kg times gravity. So have we been given mass? Mass is 75 kg. Multiplied by what is gravity? So gravity we've been given is basically 1.6 Newton per kg. Then if you multiply, you know that this kg and this kg cancels. Then 75 multiplied by 1.6 will end up with 120 Newton. So 120 Newton is basically the answer. Let us move to question C. A light truck of mass 2000 kg accelerates from rest at a rate of 1.5 meters per second square. Calculate the force required to accelerate the car at this rate. So we know that force which we are asked to calculate is given by mass times acceleration. Have we been given mass? We've been given this one, which is 2000 kg. Have we been given acceleration? We've been given to be 1.5 meters per second square. So we substitute 2000 is in kg. Remember, mass is always in kg, multiplied by 1.5 meters per second square. Then we are going to end up with basically 3000 Newton. So 3000 Newton is basically the required force to accelerate the car. Because if this force that we apply is less than the force acting on this car, it will not move because it will be less than that. It will maintain. If it's equal, it will maintain. So it has to be at least this to accelerate the car. So basically, this is how you answer this question to get the 5 marks. Let us look at question B3. Figure B3.1 is a diagram showing a uniform meter loom freely pivoted at its center. A Newton meter is hung 20 cm from the pivot, while a 4.0 Newton weight is suspended from 40 cm from the pivot. The meter loom is in equilibrium. Question A. State the principle of moments for a body in equilibrium. So the question is basically asking us to state the principle of moments. So the principle of moments states that for a body to be at equilibrium, the sum of anti-clockwise moments, we call it M1, must be equal to the sum of anti-clockwise moment, we shall call it M2. So once these two are equal, what this implies is the body will be in equilibrium. So once this principle holds, the body will be in equilibrium, and we know what the moment is. So the moment basically M is given by a force times the perpendicular distance. So this perpendicular distance should be in meters, and force should be in newtons. This is the moment. So once this odds, then the body will be at equilibrium. Let us look at question B. Calculate the reading on the Newton meter. So now what is happening here is we have the pivot. So the 4.0 Newton is acting downward. So it's pulling this the meter load down, because here there is nothing to the other side. But this Newton meter is holding it upward. So if this has to be in equilibrium, what it will mean is the moment which is the product of the perpendicular distance from the pivot and this force 2, must be equal to basically this perpendicular distance from the pivot of the 4 Newton, which is F1. So when these two are equal, then it will be in equilibrium. So we know F1, we know the distances, but we don't know F2. So what this tells us now is, let us find the moment of these two. We equate these two and solve for what is unknown, because we are being asked to find the reading, and this reading will be the force, which will be F2. So it will be the moment is equal to basically force 1. What is force 1? So the force 1 is what we've been given, this, which is the 4 Newton, multiplied by the perpendicular distance from the pivot, D1, must equal to force 2, which we are looking for, times the perpendicular distance from the pivot. Now distance should be in meters. So the force 1 is basically 4 Newton. We are multiplying by the distance. Now this distance is 40 centimeter from the pivot. So this 40 centimeter should be converted to meters by dividing by 100, because there are 100 centimeters in 1 meter. So we end up with 0.4 meters. So similarly, this one will also be converted to become 0.2 meters by dividing by 100. So we are multiplying by 0.4 meters equals basically F2 is what we are looking for, then multiply by 0.2 meters. Then when we multiply this, we are going to end up with basically 1.6 meters, Newton meters, is equal to basically F2 multiplied by 0.2 meters. Then we are looking for F2. So basically, remember these are meters unit. So we have basically F2. We are going to divide both sides by 0.2 meters. 0.2 meters. So what you notice here is basically this one and this one cancels, so that we have basically F2, which is force 2. Then this meter and this meter cancels. Then we have 0.2 into 1.6. We end up with 80 Newton. So 8 newtons will be basically the reading on the Newton meter. Let us look at question C. So we've just calculated this to be basically 80 Newton. C. State with a reason whether the Newton meter reading would increase or decrease when the 4 Newton weight is moved to a distance of 30 centimeters away from the pivot. So now what will happen is basically we are moving this to now 0.3 meters, which is 30 centimeters. So now what will happen is basically here we are no longer multiplying by 0.4, we are multiplying by 0.3. So now what will happen is we call this M1. Then remember this is M2. So M1 now becomes 4 Newton multiplied by 0.3 meters, which is now 1.2 meters, Newton meters. So now what you notice here is because the moment has reduced, what will happen is basically what you are putting here now is 1.2. So this 1.2 we divide now by the same point 2, which has not changed distance. What will happen is F2 now will become smaller. It will become just basically 6. It will just become 6 Newton as the reading. So now what this tells us is basically when we move the 4 Newton weight to a distance of 30 centimeters away from the pivot, basically the reading. So the reading on the Newton meter reduces. So it basically reduces. So basically this is how you answer this question to get the 5 marks. Let us look at question B4. A small hard ball of mass 0.14 kg is thrown vertically upwards and reaches a height of 12 meters above the point from which it is thrown. Calculate the work done in lifting the stone to the height it attains. So basically we are being asked to find the work done. Make sure to understand the question. So how do we find work done? So work done is equal to basically force multiplied by distance. So this distance in most cases is height, okay, which is the vertical height. So make sure that you know that. So let us look at what we've been given. What have we been given? So we've been given the mass. So this mass can help us to find what? The force, because this is vertically upward. So gravity is basically 10 newtons per kg. Then we've been given the height, which is 12 meters. So let us find force. So force is given by mass times gravity. So it's just basically 0.14. Remember, mass is in kg multiplied by 10. We are going to end up with 1.4 newtons as our force. So now, having found the force, we can substitute. Force is 1.4 now, multiplied by Newton, multiplied by the height. What's the height? Is 12 meters. Remember, the distance should be always in meters. So when we multiply these two, we are going to end up with basically 16.8 joules as our work done. We move to B. What is the velocity of the ball at the maximum height? Okay, so at the maximum height, what is happening? There is no movement because the ball is moving upward, then it reaches the maximum height, then before it just start coming down, this is the maximum height. So there will be a momentary stop. So velocity will be 0. Okay, so at the maximum height, the ball stops just before it starts coming down or falling. So because of that, basically hence velocity is 0. That is what is happening. So basically the velocity there is basically 0, which is 0 meters per second. C. On a wind day, the same stone is thrown upwards with the same energy, but fails to reach the height it reached earlier. Why does it happen like this? So basically the question is, why is it failing to reach the height reached earlier? So basically the key answer there is because of the drag force. So now on the wind day, what is happening is this drag force is high. So the wind is blowing a lot, and the ball, the stone, is acting perpendicular to the direction of the wind. So in that process, because there is so much wind resistance, it's losing some energy, so it cannot reach the same height. So it's experiencing both vertical resistance, which is the gravitation, and the horizontal resistance, which is coming from the air resistance. So because of the drag force, it cannot reach the same height. So basically this is how you answer this question. So the key is the drag force is high. The drag force is high on the wind day than when there is no wind. So basically this is how you get the 5 marks. Let us look at question B5. Figure B5.1 shows a transverse waves. So we have basically displacement in meters, then we have distance in meters. Question A, find the number of waves in figure B5.1. So there is a temptation to just come and pick this 6. Now this 6 is not measuring the number of waves we've been asked to find, but the distance traveled by these waves. So how do we find the number of waves? Is for us to understand what makes a complete wave. So a complete wave is basically the movement from the resting position to the crest, then to the trough, then back to the resting position. This is a complete wave. So now we need to start counting from this 1, 2, 3, 4, 5. So there are basically how many waves? There are 5 waves. Alternatively, you could measure the distance from one crest to another. This is a complete wave. Okay, that's a complete wave. So you could measure basically 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. You still get it correct. So basically this is how you answer this question. Let us look at question B. What is the amplitude of the waves generated in the figure above? So the first thing that we need to ask ourselves, what is an amplitude? So an amplitude is the distance from the resting position to the crest or trough. Remember, the resting position is this along this line. So the distance from basically from here to here, this is amplitude, or from here to here, this is an amplitude, or basically from here to here, which is also an amplitude. So that's the distance we are being asked to find, and we've been given the height. This height is 5 meters. So 5 meters is basically how we find the amplitude. We move to C. Calculate the speed of the waves above if the number of waves in figure B5.1 are produced in 2 seconds. So basically there are 2 methods that you can use, but we are going to go with the quickest. We know what the speed. So speed is given by distance over time. What is the total distance traveled by these waves? The total distance traveled by these waves basically is equal to 6 meters. So if we were to find, like we put here, the distance is 6 meters, then time is we're told is 2 seconds. So this makes it easier. So 6 meters over 2 seconds, we end up with basically 3 meters per second. This is the quickest way you can find this to get the 2 marks. Then the other method that you can use is basically to find, you need to find basically the wavelength, which in this case will be given by distance traveled by divided by the number of waves. So distance traveled is 6 meters, then we divide by the number of waves, there are 5. So we end up with 1.2 meters as the wavelength. So remember, why are we finding wavelength? We know that velocity, which is the same as speed, is given by wavelength multiplied by frequency. Then next we need to find the frequency. So what is a frequency? So frequency basically is equal to the number of waves completed per second. So to find frequency, we need to find basically divide the total time, which is 2 seconds, by the number of waves, so that we know if in 2 seconds we are finishing 5 waves, what time are we taking to complete 1 wave. So the period will be basically 2 divided by 5, which will give us 0.4 seconds. Now the relationship between a frequency and the period is that frequency is equal to the 1 divided by period, so which will just be 1 divided by 0.4 seconds. We get basically 2.5 as. So once we find 2.5 as, we can find now velocity. So velocity is equal to now basically wavelength is 1.2 multiplied by a frequency, which is 2.5 as. When we multiply these two, we are going to end up with 3 meters per second, which is the same. So this one is much more quicker. You save some time, but whether you go with the other one or the other one, you still end up getting the same answer. Let us look at question B6. Figure B6.1 shows light in air striking the vertical side of a rectangular glass block at an angle of incidence 60 degrees. The refractive index of glass is 1.6. What is a refractive index? So refractive index, basically this is just the measure of the bending of ray of light when it passes from one medium to another. That is what is known as refractive index, and this is generally given by the refractive index is simplified by the Snell's law, which is basically the ratio of the refractive index of two media is equal to the sine of angle of incidence, where it's coming from, then the sine of reflected ray. So in this case we have this. Now because it's coming from the air, the refractive index of air is basically 1. So this one just simplifies to a sine I over sine r. So this is the standard ratio, which is a measure the bending of light. So as you see, it's coming from this light. Instead of continuing like this, it has bend because it's entering a more denser media. So what happens is when the level of light moves from a less denser to a more denser, it bends towards the normal, and this is the normal. If it's coming from a denser to a less denser, it bends away from the normal. Okay, let us look at question B, Roman numeral 1. Calculate the angle of refraction R. So basically this is the angle of refraction R, which is this one. Then we know this is 60. Then we know what this is, 1.6. So this is straightforward, so just a matter of substituting. So we're going to have basically 1.6 is equal to sine 60 over sine r. We are looking for r in this case, so cross multiply. So we are going to have 1.6 sine r is equal to sine 60. Then we divide by 1.6. We divide by 1.6. So we are going to end up with basically sine r is equal to sine 60 over 1.6. Then we solve for r by introducing the inverse of sine, so r becomes sine inverse, then a sine 60 over 1.6. Then at this point you can use our calculators. When you use our calculators, we are going to end up with basically 32.77 degrees, which is when rounded off to give us 32.8 degrees. That's the value of r. We move to Roman numeral 2. What is the critical angle of the grass block? So basically the critical angle in this case is we are looking for the angle in such a way that as this ray of light is moving from a denser, now this is the denser, which is the grass block, then it's entering the less denser, it's coming out here in such a way that it's, instead of coming out away like this, changing the direction away from the normal, it follows this direction in such a way that the angle of refraction is exactly equal to 90 degrees. So we are looking for this angle in such a way that this angle of refraction is basically equal to 90 degrees. So what angle are we looking for? We are looking for this angle of incidence, which is this angle. That's the angle we are looking for. Such a way that what should be the value of this angle, such a way that when this light it's coming from the denser to a less denser, it's this boundary, it goes this direction. Okay, that's what we want. Okay, if this angle is greater, then it will not it will go back like that. That's the angle we are looking for. So let us find that angle. Now how do you find that angle? So critical angle generally is given by this is the simplified is given by 1 over the reflective index of the media. In this case is the block. So that's what we are looking for. So this is a simplified. So if you are interested in knowing on how to drive this formula, please check out for the video on our channel where we demonstrate step by step on how to drive this formula. So hence now critical angle, which will be C, the angle of incidence, in such a way that the reflected ray is at 90 degrees when it's coming from the grass block to the air. So we have a sine inverse, then 1 over what's the reflective index of the block is 1.6, like that. Then we can simplify. So when we use our calculator, we're going to end up with 38.682. 38.682. When simplified to one decimal place, this becomes 38.7 degrees as the angle of incidence that will make it move in this direction. So this will be the value 38.7. So basically this is how you answer this question to get these full marks. So it's important that you understand these key concepts. Let us look at question B7. Explain what is meant by Roman numeral 1a, magnetic field. So magnetic field is basically the region around the magnet where the force of magnetism acts. So basically it's in a region around a magnet where the force of magnetism acts. Then Roman numeral 2, electric field. So electric field is also a region in space. Now this is space in which a unit positive charge experiences force. So basically that's the definition of the two. Then a beam, Complete the diagram in figure B7.1b to show the pattern and direction of magnetic field lines in the space around the bar magnet. So basically what we need to know is the direction of magnetic field. They come out from north, then they enter from south. So they will be coming out from north in this direction, then they will be entering south. So they come out from north, they go and enter south. So this is what you need to know. So they enter south, then they come out from north. So in this is what needs to be done. Let us move on to the next question, which is C. Figure B7.1c shows a positively charged sphere S placed near to an initially uncharged isolated conductor AB. Complete the diagram to show the charges induced in the diagram. So basically we need to show the charges induced in the diagram. So according to the first law of electrostatic, what will happen is basically induction is we use the principle that like charges repels while unlike charges attracts. This is what the first law of electrostatic states. So because this is initially uncharged, what will happen is basically once this one is brought near, since this is a positive or the negative, because if this is uncharged, it means the positive and the negative are equal, such that the net charge is 0. So once the positive is brought near, what will happen is the electrons will be attracted to protons, which are the positives. So the positive charge, which are proton, will attract the negative charge. So these will negative charge. Then the positive charge in this neutral charge will be repelled, so they will come in this direction. So this is basically what will happen. Remember, the first law of electrostatic states that like charges will repel each other, while unlike charges attract each other. So this is basically what happens. So this is basically what you do to get the 5 marks. Let us look at question B8. Figure B8.1 shows an electrical circuit containing 2 resistors. So we have the 6 ohms, 2 ohms, and the voltage, which is 16 volts. Question A. On figure B8.1, draw on the circuit to show how voltmeter will be used to measure the potential difference across the 6 ohms resistor. Okay, so because we are only focusing on 6 ohms resistor, what is going to happen is we need to put a voltmeter somewhere here. We shall call it V. Then we join this like that. So basically this is how you put the voltmeter to measure the potential difference across the 6 ohms resistor only. So that's A. B. When the switch S is closed, calculate the current through the ammeter A. The current through the ammeter A. So basically, since what is happening here is we have this. So what we need to find is we need to find the combined resistor in the series. So the combined resistor, that's the first step, because we're asked to find the current through A. So A is measured in what is used by this and that. So the combined resistor, we need to find it, so that we use this formula that basically current is equal to a voltage over resistor. Now we know that voltage is a multiplication of current and the resistor. So what we need to do is the first step is finding R, which is just basically R1 plus R2, because we only have two resistors here, which will be 6 ohms plus 2 ohms, which will give us 80 ohms. So 8 ohms is the total resistor in this circuit, because it is in series. If it was parallel, resistor was going to be R1 multiplied by R2 over R1 plus R2. This is for parallel. So having found that, we can now proceed to finding current, which will be basically volts is 16 divided by resistor, which is 8. We end up with basically 2 amps. So 2 amps is basically our current flowing through this circuit, which will be the reading under the ammeter. Let us move to the next question. See, what is the potential difference across a 6 ohms resistor? Potential difference. So potential difference basically in the series will be basically different according to the resistor. So potential difference is basically the voltage, okay, the energy between 2 points in a circuit. So now it will be the energy passing through that. So if we are to now to find, it will be basically voltage times basically current times resistor. So voltage is a potential difference, which is equal to current in the circuit, which is we just found it to be 2 amps, then multiplied by the resistor, which is 6 ohms, which will just give us basically 12 volts. So 12 volts is what is passing, that is the potential difference through this. If the question was to find through the second resistor, it will still going to be the same, which will be 2 amps multiplied by what is the resistor there. Resistor is 2, so it will be multiplied by 2, which will give us 4. So 4 volts. So when you add these two, you are getting back to 16. So 4 plus 12 is 16. So this is basically how you answer this question to get the 5 marks. Let us look at question B9. Uranium 238 decays to form a nucleus of thorium by emission of an alpha particle. Thorium as a symbol, this is a symbol. Question A, what is the meaning of nucleon number? So nucleon number is basically the definition in this case is the total number of protons and neutrons in a nucleus. So the nucleus of an element or an atom, that's basically the nucleon number, or this is also known as a mass number. We go to B. Write a decay equation to show how uranium decays to thorium after emitting an alpha particle. So an alpha particle is basically helium. So what is happening now, just need to show this decomposition. So we have 238, then you have then this is 92, then this decays to thorium, which is 234, then this is 90, then plus basically helium, which is 4, then E, then 2, then plus energy. So this is basically what is happening. So these are the changes which is happening, which is the emission. We go to C. Thorium, this one decays to an isotope protactinium Pa by beta decay. Write decay equation to show this process. So similarly, we are going to start with 234, then this is 90, then this decays to this Pa, then plus basically remember a beta is just basically an electron, then plus energy. So now what is going to happen is basically it's going to gain one electron, so this one becomes 91, so that these two, when you add them, they give you this number. Then after gaining one electron, it will be have more negative than positive. So what is going to happen is one neutron, which is zero charge, will become a proton. So what will happen is the overall nuclear number is not changing, because just a change from a neutron to a proton. So this number remains 334. So this is the decay equation that you need to write for you to get the 5 marks. So basically this is how you answer the questions from section B to get optimal marks. Thank you for joining me. Please join me on section C, where you're expected to answer 2 questions out of 3.